Hi, this is Ishita Rai from BE E&TC, roll number 11. Today, I'm here to give a presentation for my machine learning submission, SPPO oral examination, academic year 2021. My topic is basically to give a presentation on concepts covered and Python program implementation for K nearest neighbors, KNN algorithm, and its distance aspects. Let's move forward. So the objective of this presentation is to understand the algorithm, the nearest neighbor algorithm, to implement that algorithm in Python, to understand the distance aspects of KNN algorithm, and to understand the use cases of both the distance aspects as well as the algorithm. Let's move forward. So before we move on to the KNN algorithm in a detailed aspect, we need to have a background check. There are certain prerequisites that are required before we start learning the algorithm. What are those? What is machine learning? Machine learning is an application of artificial intelligence that provides systems the ability to learn and improve from the experiences without being explicitly programmed. So basically, we are training the model to predict the future without actually programming it. The second category is what is supervised learning. So machine learning has three categories: supervised learning, unsupervised learning, and reinforcement learning. Our major focus will be on the supervised learning. So supervised learning is basically a process in which we provide input data as well as output data to the training model to predict with full accuracy. The third question that comes before we dive deeper into the algorithm is what are the classification techniques. So there is classification techniques is nothing but a process wherein an algorithm is used to map the input data to a specific input category. Now, why do we need classification techniques? Classification model actually draws some conclusion from the input data given for training. So there are two phases. There is training phase and the testing phase. And what are we doing here is we are given a certain amount of input and output, and we are training the model to predict the output which matches the actual output which was earlier given. So this was the necessary prerequisites before diving into the KNN algorithm. Let's move on to the KNN algorithm. So what is KNN algorithm? The K nearest neighbor algorithm is nothing but a process like making friends. Yes, you heard it right. So we tend to be friends with people who have similar tastes, and so does the data. So when we have a huge data set, what do we do here is basically we classify it into categories. So the similar types of data stays in the same cluster. So this is the concept of KNN. Now moving on to a deeper definition of KNN, it is basically a simple algorithm, which is one of the major used algorithm in today's date. It works by calculating the distance of one test observation from all the observations of the training data set and then finding a K nearest neighbor of it. So it basically consists of a dependent variable and an independent variable. K stands for the number of data set items or data points that are considered for the classification. So what is the classification approach? Now, K-means clustering algorithm involves a certain number of steps that need to be followed in order to implement KNN. Now, what we have to do is basically we have to choose the number of clusters. So these clusters can be K, which is a variable. Now, we have to select random data points, and we have to have a center of those cluster random data points. So that random cluster center can be K. Now, after we've selected a cluster center, we have to select it in such a way that that they are far as possible from each other. So the centers of the cluster should be as far as possible. Now, the distance between each data point and each center is calculated, and there are various ways to calculate that distance. That is the distance aspect we're talking about. So we'll be going into the distance aspects in the deeper detail in the coming slides. So what we do is basically, after we've calculated that distance, a data point is assigned to a cluster whose center is nearest to that data point. So basically, what we are doing is we are calculating the distance, and the data point that is nearest to the center is belongs to that one cluster or that class. Okay, so we have to repeat this procedure until any of the following criteria is followed. Now, what are the criteria that needs to be followed? Either any one of them should be fulfilled. So the first one is the center of newly formed clusters do not change. Yes, you cannot change the centers of any clusters. Second, the data point remain present in the same cluster. So it should be in the same cluster. And the third one is that the maximum number of iterations is reached. So this was the approach of KNN. Let's understand the logic behind KNN. So you know that it is one of the most simplest and the lazy algorithm known, right? So to understand it clearly, more nicely, look at the image that is shown to you below. So you have two axes. You have a y-axis and you have an x-axis. Now what you can see here is you have two classes, class A, which is of red color, and class B of green color. So you can see there are stars in red and triangles in green. And you have a question mark in the center, which is of yellow color. What does that question mark represent? Now that question mark is basically a query point. What we are doing here is we want to know which class it belongs to. Does it belong to red or does it belong to green? How are we supposed to know? We are going to apply KNN here. Now, let's say the value of k equals to 3. Now, as I told you, k is nothing but the nearest neighbor of that query point, right? So we've taken a query point question mark, and we know that the value of k is 3. So as you can see in the smaller circle, that the inner dotted circle that you can see, there are 3 data points that are near to that question mark. There are 2 triangles and 1 star, right? So what happens here is basically these are taken into a cluster since they are the nearest to the query point. And the inner dotted circle represents that one cluster. So the question mark belongs to which class? It belongs to class B. How do you know it belongs to class B? Because the majority of data points in that cluster or that class are green. So the class is decided on the basis of the majority. Similarly, for k equals to 5 or k equals to 7, let's just consider k equals to 7. So now you can see the outer ring of that circle or outer circle. So the outer dotted line has 4 red stars and 3 triangles in it. So these are the points that are near to the question mark. Okay, so I cannot change centers. That was my one condition, that I cannot change the data center, like the cluster center, right? So keeping that cluster point constant, center point constant, I have to see how many, I have to choose 7 neighbors that are near to that point. So when I have to choose 7, you can see that those 4 stars and those 3 triangles are near to the query point. So that make one cluster. Now, which class does that cluster belong to? It belongs to red. Why does it belong to red? Because the majority of the data point in that outer circle are red. So you can see there are 4 stars and 3 triangles. That is why my outer circle or my outer cluster or my outer data set or the entire cluster belongs to class A, because majority of the stars are in A. So this is the logic behind KNN algorithm. And we use this algorithm to find to classify data points into clusters. So this was the logic. Now, like I told you earlier in the previous slides, I told you here that the distance is calculated between the data point and the cluster center. Now, to calculate that distance, we have a lot of distance matrices available to us. And we, for any algorithm, how do we choose the perfect distance matrices? It is basically, we have to choose it on the basis of what works for us. Okay, so we have to choose the most appropriate one. And there are a lot of variety available. So we are going to talk about the few that are frequently used. So the first one is the Euclidean distance. Now, what is Euclidean distance? Euclidean distance is basically used by default in KNN algorithm while implementing it. So it is basically the distance between the 2 points, and it is basically the measure of a true straight line between the two cluster points in the Euclidean space. So as you can see, if you consider the green as the x and red is as the y variable, the Euclidean distance between them will be the square root of their square of their differences. So this is the Euclidean distance, and it is the default metric that sklearn library of Python uses for KNN. So this is the so if you haven't mentioned any distant matrices, it's going to take it as Euclidean. Coming to the next one is Minkowski distance. So what is Minkowski distance? As you can see, Minkowski distance is basically the distance between the 2 points for real valued vectors. Now, when I talk about real value vectors, or I talk about normed vector space, what does that mean? It is basically a space which follows these conditions. So there are 3 conditions for a space to be a normed vector space. What are those 3 conditions? The first one is the zero vector. That is, zero vector will have 0 length. Scalar factor, that is, the direction of vector doesn't change when you multiply it with a positive number through its length, but its length will change. That is, the direction of a vector will not change if you multiply it with any positive number, but the length of the vector will change. And the third is triangle inequality. What does that mean? That is, if distance between any points is norm, then there always will be a straight line. So you can see, if there is a normal distance, if it's a norm distance between 2 vectors, then the distance is going to be a straight line. So this is Minkowski distance. Now, if you look at the formula closely, it is very similar to Euclidean distance. The only difference is, for a Minkowski distance to be Euclidean, the value of P is 2. So if I substitute the value of P as 2, this formula will turn into the Euclidean distance. So along with Euclidean distance, Minkowski is also a distance matrice that is used very frequently in KNN. The third distance matrice, or the third distance aspect of KNN, is Manhattan distance. Now, what do you mean by Manhattan distance? Manhattan is a city in, New York is in Manhattan. But why is it named as Manhattan? Do you know the largest number of taxis available in Manhattan are the largest in the world, which is why this is known as taxi cab distance or city block or Manhattan distance formula. Anyway, irrelevant to it. It is basically distance between 2 points, and which is the sum of the absolute distances of their Cartesian coordinates. So what are we doing here is, we are taking the absolute difference of their Cartesian coordinates, as you can see in the picture. Now, why is it used? See, when the dimensions of, when the dimension of the model increases and the variables are not in the similar type, then Manhattan distance comes into rescue, because then it helps us to give a better prediction to our model. So this is the third distance that we've come across. The next one is the cosine distance. Now, cosine, as the name suggests, is the cos theta value, right? So this distance matrix is used to calculate the similarity between 2 vectors. And how is it measured? It's measured by the cosine angle between those vectors. So that determines whether the 2 vectors are pointing in the same direction or not. So this type of distance matrice is specially used in text analytics and to find similarities between 2 documents. So if there is a textual data in your for you to classify in KNN, then you can use cosine distance, because what happens is, it checks similarities between 2 documents. So let's see, if a document has a particular word that is repeated in the other document very much times, then it's going to calculate the number of times a particular set of word appear in the other document. So that is how it it checks for the similarity, and that is why it is used for textual analysis. So that was cosine distance for you. The next distance aspect is known as Jacquard distance. Now, what is Jacquard distance? The distance metric is used to mainly calculate the similarity between 2 vectors. This is so fixed, right? What happens is, it is measured by the cosine of the angle between the 2 vectors. That is also true. But this approach looks at the 2 data sets and finds the incident where both values are equal to 1. So you can see that it is finding an intersection and a union, right? What is it doing is, basically, it finds a point where both values are equal to 1, And it is also known as frequency that one-to-one match. So it is basically matching one-to-one frequency. So Jacquard distance is also used in textual analysis. These were the few distance matrices that we've come across. There are many more others that are used. However, these are the ones that are very frequently used. So you will often come across all of these matrices. Coming up to the next slide, we are going to talk about the implementation in Python. So you know that KNN, we have to implement it using Python, and Python provides a package called skykit and stykit, and it also has various libraries that are very efficient to use. That is why we've chosen Python here in the first place. So what are we gonna do here is, like all other programs, what are we gonna do is we are creating a feature. We are creating target variables, and like I told you that it has two phases. It has a training phase and a testing phase. So we're gonna split the data into a training data and into testing data. Now we're gonna generate a model using neighbor's value, which is your case value. So what are we gonna do is we are generating a model with using neighbor's value. So now we're going to train the data model. Now, how are you going to train the model in? How are you going to train the data into a model? By using fit function. That is why it's written fit there. I'm going to talk about it in my further slides. So that is going to help us predict future. Now you know Python, and now you know what KNN is. Let's implement it. Moving on to the code. Now, I haven't really put a screenshot of my entire code here because it wasn't possible in the first place. And secondly, I wanted you to have a clear look at how it actually runs. So I just have a glimpse of a particular function that I would like to talk about here. And then we'll explain to you the further code as we move ahead with the presentation. So what I've done in my first line of code, as you can see, I have imported this library called sklearn.neighbors in Python. And in that library, there's a function called kneighbors classifier. So what does that function do? I'll tell you about it. So I've declared a variable called knn. Knn is my variable. And what I've done here is I have written that function kneighbor classifier, which I've imported from the library. And I've passed in a parameter. So the parameters that I've passed in is n_neighbors equals to 5, which is nothing but my k. So what I'm doing here is I'm calling out the function, and I'm passing out my parameter as k. So k equals to 5 in this code. Okay. Now what happens is in the second code I've written df equals to pd.getDummies. Now for you to understand the entire code, for you to understand this, we have to look at the entire code, which we will be looking at as we move ahead with the presentation. But to give you a glimpse of it, my data set uses a lot of textual data. So what happens with the distance matrices here is when you're applying KNN, you need to have numerical values, since distance needs to be calculated in numerics, right? So the textual data has to be converted in numerics. And how do you do it? By dummies function. So what I've done here is I've declared a variable called df, and I've assigned it to pd.getDummies. Okay, so pd is nothing but pandas. So I've imported pandas library in Python, and there is a function in pandas called getDummies, which converts my textual data into numerics. So I have converted it into df, and I've passed it. Okay, now in the next line, I've written df.shape. That is, I want to see the shape of df. What do you mean by the shape of df? The shape of df is nothing but your outline of the entire schema. So it's going to give me the number of rows and columns that data set has. So it has returned 101, 117. What are these? These are rows and columns that are there in my data set. In my next line of code, I've written x equals to df.drop type axis equals to 1. What does this mean? See, in my entire data set, there are a lot of columns there. Okay, so for that, in those columns, I have a column called type. And how do I know it's a column? Because I've written axis equal to 1. So if I had to mention row, then I would have given axis equals to 0. But 1 here signifies that it's a column. So what I mean here is that x is equal to drop. That means all my columns excluding type column should be considered as x variable. And then in the next code, I've written y equals to df type, which means y is equal to that particular code. So I have I have basically my I have divided my data set into two variables. So x is basically all my columns from 0 to type, just one before type. So basically I've excluded type, and all the rest of all the columns are in x, and that one particular column is in y. So I've got two variables now. So to implement knn now, it's the perfect time, because I have one dependent variable and one independent variable. So my x is the independent variable and y is my dependent variable. Next in the line of code, you can see I've implemented knn.fit. Now, like I told you earlier, fit is nothing but a function to train your model. Okay, so the model that you created, knn, you're trying to train it by doing what? By passing the x and y parameters into it. So when you write knn.fit, the compiler, Python knows that, okay, I'm going to take the entire variable knn, I'm going to turn it to a model by training it, by passing the data set into it. Now, when my data set is passed into it, you can see the output here. For k-neighbor classifier function, you can see the algorithm is chosen as auto, which is automatically set. But our only major concern here is metric. So if you look at it closely, it says Minkowski. That means Python is already implemented it using Minkowski. That is, it looked at the data, it scanned through the data, and Python thought, okay, I think Minkowski will go well with the data and it will help me predict better. So that is why I've chosen Minkowski here. If you want to change your distant metric, then you have to pass it in your bracket that you've opened earlier. So in your fit function, you would have to probably write comma metric equal to the distance name. So let's say if you want to have Euclidean, or you want to have Manhattan, or you want to have Jacquard, or whatever it is, you need to mention it there, and then Python will implement it. For here, I have not written any specific metric. That is why it has chosen Minkowski based on its own classification. Okay. And in the next line of code, I've written knn.score. Now, score function in Python basically returns the accuracy of knn. So what do I want is, basically, I want the most accurate result of my knn algorithm. So if Python used Minkowski basically to find the distance, then the accuracy of my model is 94%. That is, my entire model is 94% accurate. So I hope you get the function of what I was trying to tell you and the functionality of my code. Now let's move ahead and look at the advantages of using knn. So the advantage of using knn is, basically, it is very simple, it is very intuitive, as you can see earlier, and as you saw earlier, and it can be applied to any data from any distribution. That is the best part. And obviously, if the number of samples is large enough, then the classification is also good. So these are a few very simple advantages of using knn. There is a limitation, however, and if there is a obstacle, there is also a way to overcome it, right? So the major limitation with knn is that it is not good to use it for high dimensional data. So what is this high dimensional data set? It is nothing but the curse of dimensionality. That is, when you have higher dimensions of data, that is, when you have, when the dimensions of your data increases from 2D model to 3D model, then applying knn is not reliable. So that can be overcome by using transformations or selections. Now what happens here is, in the feature transformation or selection is, there are certain cases when you have one data point as, say, 10, and the other one is 2 lakh. So the distance between is very long. knn is all about distance, right? So if the distance is very large, you cannot apply that algorithm. It will be of no use. So what are you going to do then? You have to scale the value of both the data points to a certain level where it matches. So you can either convert it into tens, or you convert it into in number of 2 lakhs, right? So when you convert it, when you scale it, then you can use knn, and that is how you can overcome the curse of dimensionality. So that was the limitation, and that is how we overcome it. Now, before telling you, before jumping onto the coding process and the proper implementation of my code, I would like to, highlight, enlighten you with the fact that how many references I've used here. The first one is obviously the book that was assigned to me in my assignment, that was Thoughtful Machine Learning with Python, a test driven approach, first edition by O'Reilly, by Matthew Kirk, and it was published by O'Reilly. The second is obviously Kaggle. Kaggle is a website wherein you can get a lot of data sets. So you will know how I got my code and how I implemented it. I'm going to talk more about it. So Kaggle is amazing if you're somebody new at machine learning and you want to practice all your algorithms, you can get data sets from Kaggle. And obviously the scikit, because there were a lot of libraries and a lot of scikit is basically a package in Python, right? So to implement a lot of libraries and functions, and to go into deep in Python, I had to refer to scikit.learn .org. So I used it, and now I'm gonna jump off to my code. Let's go to the code. So here you can see what I've done here is, okay, so it is named as zoo, and I'll tell you why it is it named as zoo. It's named as zoo because it's a data set of animals, and I found it on Kaggle. So what you have to do firstly, I've used Google Colab here. It's much easier to use. You can use Jupyter as well, and in Jupyter also you will have to upload the CSV file. So I got my data set from Kaggle. So this was the zoo data set that I got from Kaggle. Now the first line of code, as it says, I've imported the NumPy library of Python as NP and pandas as PD. So NumPy is basically used for numeric operations, and pandas, so everybody knows about pandas, right? So pandas give you the function to read these CSV files. That is why I've imported pandas here from Python. So the second line says df equals to pd.read underscore CSV. What does this line mean is, I've created this variable called df, and I've imported pandas in it, and I've accessed the function read underscore CSV. That means import the CSV file into my code, and I've given my data set zoo.csv. So that is the file that I got from Kaggle, right? In the third line of code, I'm going to run it as I go ahead. Okay, so in my third line of code, you can see df.shape. Like I told you earlier, your shape is nothing but it gives you the glimpse of your data set. So you can see there are 101 rows and there are 18 columns. Now my next line of code says df.head. What does head means? Head means it'll show you the top 5 rows of the data set. Now obviously I won't be able to show you the 101 rows of my data set, right? So I have used my head function here to show you a gist of my data. So if you can see here clearly, there are 18 columns, there are 5 rows that are visible to you here, and my last column is type. Now type column is very much of use to us because you saw in the presentation that I've defined it as y variable, right? So coming down, you can see that I've used df.columns. It basically means that I wanted Python to return me the names of the columns. So you can see, to get the names of my columns, I wrote df.columns, and as the output, I got column name as animal name, hair, feathers, egg, basically all the headings of my columns. You can see it on the data set above, right? Coming down next, I wrote a function called df type dot value underscore counts ascending equals to true. What does this mean? What I've done here is, if you look closely to the type, I've taken this particular column and the rows with it, and I wanted to arrange it in ascending order. So you can see here, Python has arranged it in ascending order for me: 4, 5, 8, 10, 13, 20, 41. This is nothing but the input. Coming to the next line, what I've done here is, this is very important. This is of the major concern. So from the line 16th to the line 24th, I have explained to you the entire part in the presentation earlier. So I won't go much into detail. You can see I've given k equals to 5. I've used dummies to convert my textual data into numeric value. And then I've used my drop to exclude the value of type. Then I gave type as, I assigned variable y to type. And that is how I got my accuracy score. what after this? So after implementing all of that, I wanted to get accuracy. Okay. So I created a function called accuracy. And for that, I chose to have my values of I. So I used a for loop here. So for I in range 352. And what does that mean? What does 3 comma 50 comma 2 means? So here in Python, what I'm trying to say is I wanted my K to differ from 0 to 50. I want my K values to go from 3 to 50 in order, and by skipping two values. Now, why am I choosing 2 as my value? Is because, see, what I'm doing here is I want my value. See, by doing this, I have created an accuracy function. Okay. So what I really want from this function is to give me the accuracy for the value of particular, like for that particular value of K. So what will be the accuracy for K equals to 3 or K equals to 5, K equals to 7, K equals to whatever, right? So what I'm doing here is I'm increasing my value of K from 3 to 50, and 2 because I want the gap of 2. Why do I want it? Because I have an odd data set and I want the even values here. So I have an even data set. Sorry, I spoke it wrong. So I have even data set and I wanted my K to be odd. Now it should go in the opposite always to have better prediction. Okay, since I have 18 columns, that is, which is an even number, I want my K values to go in odd function. So see, what I've done here is I've created a variable called nay, and I've given K neighbors classifier. I've used that function and I've passed my parameter equals, sorry, I've passed my parameter and neighbor equals to I. What I'm doing here is I am basically assigning the K value equals to I, and I, the range of I is 3 to 50. Okay, so I've done that. And now what I'm doing here is in the second line, you can see here, is nay.fit comma xy. Basically, I'm creating a model called nay. I want to see the accuracy of nay. And to train that model, I'm passing my data set in it. So I'm passing the entire data set. After I do that, I've created another variable called train underscore acc, which is going to give me the mean of that prediction. So what is happening here is np.mean. NP is what? Nothing but your numpy. Numpy is your numeric library in Python, and it has a mean function, and I'm calling that mean function here, bracket, and then I've written nay.predict. Nay is nothing but my model. Dot predict is nothing but a function that is going to return me the value of x equal to y, which is basically for every value of x and y, my accuracy. So I am doing nothing but training my model to give me the accurate result. So in the next line, I have written acc.append, which is I'm appending the value of train underscore acc comma I. So what does this mean is basically give me the accuracy for a particular value of K. So I have to basically divide it into two classes, right? And I have two variables. X is my independent variable, Y is my dependent variable. So now I wanted to see if my function is working or not. So I wrote acc, and it is nothing but is going to show me the value. So you can see for a value for K equals to 3, my accuracy of my model, which model? Nay model, is 98%. For K equals to 5, the accuracy of my Nay model is 94%, and so on. It goes on from 3 to 50th by skipping two numbers in between. So basically every odd number, I've taken all the odd numbers here. So now that I have all the results of my accuracy, I want to know which is the number, which for what value of K am I going to have the maximum accuracy. And I've used a max function here. So I've written max of the entire accuracy data set. And now it has given me 3 and 98%. So my answer would be that for every value of, like for every time you have K equals to 3, your model is going to be highly accurate. That is, you're going to get the actual prediction. That is very close, because 98 is very close. Now what I want to do, I want to plot this in a graph so that it looks much better. And it is not, see, reading all of these values here is very difficult. So you want it to have a very clear representation of it. So I want to plot a graph. Now to plot a graph, I've imported a library called matplotlib. plt.pyplot. This is a library in Python which helps me plot my data. So I've imported it as plt, and in the next line of code you can see I've written plt.plot, and again np is nothing but my numpy. I'm calling out the library and numpy dot arrange, which is the function of numpy, and I've passed 3 to 50, 50 comma 2, which is nothing but my value of k from 3 to 50, while skipping two numbers in between, that is for every odd value of k from 3 to 50. And I've given the range, so I from 0 for I in ACK. So basically I of 0 from the value of I of 0 to the entire range. Okay, and then I've labeled my plt.x label as nearest neighbor. You can see here it's written x-axis as nearest neighbor, y-axis is training accuracy, and then text. So text is basically my output. So when I run this code, you can see here I get the value and my graph. So if you notice very carefully, the graph is the highest at 0.98 approximately to the value. If you see, the x value has to be 3. So it is nothing but your value of k. And that is my implementation of this data set. And I've successfully implemented KNN in Python. I hope you understood it, and thank you. So continuous improvement is better than delayed perfection, and which is why your feedback is important. Please let me know if you have any queries. Thank you.